Okay, so 3.5 is basically a lesson where we're gonna put it all together. You know, can we take what we know about finding extrema and inflection points uh, and come up with a graph for each of these. So we're gonna do 4, and I pretty much hit the range of what you will look for. Here's a polynomial, here's a rational function. This is just a combination of with a square root, and here's a trig one. So it kind of gives us 4 good examples to look at. And so the first thing I'm going to do is I got to kind of think about, before I do any calculus, I got to think about the pre-cal that we talked about with a lot of these, kind of what's the graph going to look like, and then I'll worry about the calculus. So when I get to part A, I see it's a polynomial, and technically on this one, we could write it negative x cubed minus x plus 2. And the reason I want to write it in that order is why? Why would I want to write it like that? So what might be helpful is in pre-cal, I taught you how to graph this type. I taught how to graph this type. Not so much this one with the trig, because it's got an x with it, but something similar. Anytime you're graphing polynomials, I would go to my notes. And in polynomials, I went through on the process of how you graph them. The first instruction I gave is, look at the leading term. If it's odd and negative, you know the end behavior. So I know this polynomial goes left, up, and right down. That's the first thing I determine. Okay? If it's easy to get the x-intercepts, I'll get them. If it's not easy, then I'm going to just ignore it and move on. So the only intercept I can see very easily is which intercept? The y-intercept, which is what? 0, 2. All right, so I'm just going to move on to that. So right now I've got the end behavior, and I've got that the y-intercept is 0, 2. Since this is a cubic, sometimes they're easy to solve, sometimes they're not. This one doesn't look very easy to solve to me. So I'm just going to move on, and well, actually it is fairly easy, yeah. So I can see real quick, so on this one, I can see real quick how to get the x-intercept. So if I set this equal to 0, we did what was called the rational root test, where you would pick possible solutions and plug them in, or do synthetic division and see if the remainder is 0. You've got to use your placeholders. See, I can see, look real quick, if I plug in a 1, I get 0. So I know 1 is a solution. So what we did last year was we picked what we thought was a solution. We wrote the coefficients, and notice since there's no x squared term, I put a 0. And we did synthetic division. And the reason I'm doing that is because whatever I'm left with here is my other factor. So let's see, -1 and nothing, -1. Multiply, I get -1, add, I get -1, multiply, I get -1, add, I get -2, multiply, I get -2, remainder is 0. So that tells me, if that happens, that what I divided by, which is, if 1 is a solution, then what's a factor? X minus 1. You got to make it a factor. And your answer is also a factor. And this is -x squared minus x minus 2. Okay, so now I know 1 is a solution at least. That's an x-intercept. Okay. All right, so let's see, is this one going to be easy to solve? I don't think maybe as much. I can take, in fact, I could set this equal to 0, factor out a negative, and that is not going to factor. You could use tri-quadratic formula. Let's see real quick, if we did quadratic formula on this, what we would get? Negative b plus or minus the square root b squared. I can stop. Why am I stopping? Minus, yeah, 4ac, inside of your radical is negative, imaginary. So no more x-intercepts. All right? So again, this is a pre-cal review on finding x-intercept, y-intercept's easy, you just plug in a 0. Okay, now now I'm gonna move to calculus. So now in the order of those things up here, extrema, points of inflection, and asymptotes. Well, I'm not worried about asymptotes. Polynomials don't have asymptotes. So am I gonna look for extrema or points of inflection next? Why?
You only have to take one derivative?
Yeah, first derivative is, you can get extrema, second derivative, points of inflection. So just go in order, okay? So now, erase this scratch work. Now we'll go to calculus and use what we've learned in calculus. So now I'll take the derivative, I get negative 3x squared minus 1. That's it. And then I'll set that equal to 0. It won't be pretty, but at least I'll know where the extrema are. So I got negative 3x squared equals 1. X squared is hang on, I make a mistake. Ooh, that's nice. I can stop here. Sorry, I can stop here. Why?
There's no real answer.
There's no real answer, so there's no extrema. No critical numbers, no extrema. This doesn't have any extrema. Okay? So there's that. Let's just make sure I didn't make a mistake. That looked right, set it equal to 0. Move the 1 over. Divide by negative 3, yeah. Yeah, I mean, if I get to here, I can't, yeah. If I go square root, I get imaginary. So no critical numbers. But what would be nice is to find so I know the concavity, so I can kind of put this picture together. See, right now, I know it has to connect from here to here. And I've got this x-intercept and that y-intercept. So now let's find the second derivative, which I would get negative 6x. Okay, so now how do I do points of inflection? I'll set the second derivative equal to what? 0. Then I get 0. Right? So now I'm going to at least get the concavity down so to help me with the picture. So anything left of 0, let's see if I plug in a negative 1, a negative 2, whatever. I plug it into the second derivative, which is negative 6x. A negative times a negative is a positive, thus it's concave up. And then if I plug any positives, 1, 2, anything like that, I get a negative, which is concave down. So that helps me now. I can see here at 0, and it has to be 0, 2, because I already had that point. So 0, 2 is a point of inflection, okay? So my point of inflection, I just usually put IP for inflection point, is 0, 2. And now I can see how I'm going to shape with the curvature. So it's going to open more up first to here. Then the concavity has to change and it has to open down. And there's your sketch using pre-cal and calculus. And the only thing I can really give, I can give my point of inflection. I can give my x-intercept is 1, 0. And I can give my y-intercept, which is 0, 2. And then it didn't ask for concave intervals, but I used it to help me graph. There's that picture. Okay? So having your, in my opinion, those pre-cal notes would be very handy right now. So for these. Okay. All right. Example 1 is done. And there's the final picture. So now example 2 is a rational function. And rational functions have asymptotes. So let's talk about example 2. An I may not use as much calculus on this, but we'll see. Okay, I'll go ahead and erase this picture. All right, so, or part B, whatever you want to call it. So y equals 3x over x squared minus 1. Okay, first thing I'm going to do, I can see the x-intercept, the y-intercept, the horizontal asymptote, and the vertical asymptote. So this was what we did back in pre-cal when we had a rational function. How do I know it's a rational function? Because it's a polynomial over a polynomial. Okay, how do I find the x-intercept? How do you always find the x-intercept? Any graph? Yes, set it equal to 0. So if I set the equation equal to 0, now you're going to say, well, how do I solve that? Well, it's fairly easy, because the only way that a fraction can equal 0 is if the numerator is 0. You need only set the numerator to 0. 3x is 0, thus x is 0. So your x-intercept is 0, 0. Well, once you know that your x-intercept is 0, 0, you also know your y-intercept. Guess what your y-intercept is? 0, 0. Now you can get your y-intercept by plugging in a 0 for x, but you're going to see if you plug in a 0, the top 0, you get 0, 0. I'm going to skip and do vertical asymptotes next, since I'm in this habit of setting something equal to 0. Vertical asymptotes, that's how we did our x-intercept. That's exactly right. You set it equal to 0. So you made y equal to 0 and you solve. So for vertical asymptote, do you guys remember what the rule, what did we do with our equation to find vertical asymptote?
You said the denominator equals 0?
Yeah, what it makes only the denominator. If it was top and bottom, be a whole, that's right. So we set only the bottom to 0. You got x squared minus 1 is 0. However you want to solve it, I would just probably factor a difference of 2 squares. And I can see that I get 1 and negative 1 for my vertical asymptote. All right, there's that. All right, horizontal asymptote. You remember the rule for horizontal asymptote, and this is also a little bit with calculus also, because as x goes to infinity, what's y approaching, and as x goes to negative infinity, what's y approaching? Anybody?
You put the coefficients on
Yes.
the degree.
That's exactly right. That's the easiest way. And so the degree of the top, though, is only a 1. The degree of the bottom is a 2. So what does that mean for horizontal asymptote? It's y equals 0. That's right. Now, I'll show you a couple of things you can do. One is you can make the degrees the same by putting a placeholder on top, by adding a 0x squared. And then you can say 0 over 1. So the rule that we have in pre-cal with a rational function is if you have ax to the m plus dot 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 over bx to the n. There was 3 scenarios. If m equals n, so if your degrees are the same, y equals a over b is your horizontal asymptote. If n is less than n, which is what we have, y equals 0 is the horizontal asymptote. But if you have the same degree, then it's the coefficients. Now, the way I showed you to do this with calculus was I showed you a trick. I said that if you want to see what is happening as x goes to infinity, just sub in infinity. All right, remember? Then I said delete any negligible parts. What's negligible in the bottom?
1.
Negative 1, yeah? Delete that. Now I said treat infinity like a variable. So your infinities would cancel, you're left with 3 over infinity. And a constant divided by an infinitely large number is 0. Okay. So y equals 0. Now at this point, I would start putting my picture together before I did any calculus. Because I can see, I'm kind of wary of the calculus for this. Why is that?
It's not going to be fun to take
It's not, that's exactly the answer. It is not going to be fun to take the derivative. So let's see, so I'll go ahead and start putting what I know. Horizontal asymptote is 0, y equals 0. Vertical asymptotes are at -1 and 1. X-intercept is 0, 0. Now, it is possible to cross a horizontal asymptote close to the origin, okay? Now, what you could do from here is we could kind of test some points just to see what the graph is doing, all right? So what I mean by that is, way out here at 2, I know it doesn't cross the x-axis anymore. The graph is either in this area or it's either in this area because of the asymptotes. So I can plug in a 2 real quick, and I see if I plug in a 2, I get 6 over 4 minus 1, which is 2. 6 over 3, which is 2. So I have this 0.22 over here, which tells me that the graph is in that area, okay? Like that. All right? In here, between 0 and 1, maybe I'll plug in a half. So I'll do y of a half. And I get 3 times a half over 1/2 squared minus 1. So I get 3 halves over negative, what is that, 3/4. Well, all I care is that it's negative. I really don't care about the answer. I care that it's a negative. So at 1/2, I know I'm going to get a negative. Wherever it is, doesn't matter. That tells me the graph is going down right here. Because asymptotes are guides. They tell you what the graph approaches. Okay? So I got that one. What does your gut tell you is doing to the left? Going up or going down? Do you think it's going down here, or do you think it's going up?
I think it's going down.
Okay, so let's see. So we'll plug in a negative 1/2. Right, because negative 1/2 is between 0 and -1. So I get negative 3 halves if I plug a negative 1/2 in, over negative 1/2 squared minus 1, which is negative 3 halves over, that's a 1/4 minus 1, that's back to a negative 3/4. So it's a positive answer. I don't care what it is. I just know it's there. So it's going up like this. And again, we did these in section 2.6 last year in rational functions. Then -2. Where do you think it's going to be? Top left or bottom left? It will be. Yeah. There you go. And there's your picture. I don't think we need calculus. Because look, are there any extrema? Do you think there's an inflection point anywhere? Yeah, look closely.
Oh, there's the
Yep, of the origin. So I'm saving myself a little time here. Why do calculus when it's not going to help me? Because there's no extrema. The only thing I have, that looks like that would be an inflection point. And they want you to do the second derivative because they want it's like a practice, it's like a review, right? So they want you to go through and do it. Well, you can save yourself some time sometimes, okay? So all I would list on this, I'd list all my information, x-intercept 0, 0, y-intercept 0, 0, horizontal asymptote y equals 0, vertical asymptote x is plus or minus 1, point of inflection at 0, 0. We're pretty sure it is. Looks like it. Can't squiggle like that without changing concavity. Okay? That's it. Okay. All right, there's that one. This one, after a while, you would be good to kind of maybe memorize what it looks like. Okay. So I call this, maybe I'm wrong, this one I think it's an upside down, but I think it's like a Nike swoosh. So anytime I see an x times the square root like this, it typically resembles a Nike swoosh. Either like this, so it's either gonna go like this or turn that upside down like that. Okay, like, have an endpoint, go like that. or it'll have an endpoint. Here's where I see the symbol, okay? All right, so let's get to work on this one. So here's what I want you to do. So question, is this a polynomial? Polynomial cannot have square roots, no? Is this a rational function? Because a rational function has to be a polynomial over a polynomial, so you throw that out. It's just some kind of weird graph. First thing I would do is get my X-intercept and my Y-intercept. Get those first. And I'll tell you there's two X-intercepts. Because it's already factored, it should be easy to figure out. Then I would think about what the domain is for this, because that's going to be critical. Because that way you know which way the graph is headed, okay? So get your X-intercept, your Y-intercept, get your domain, and then do Y prime, and we'll talk about that. So let's take a couple of minutes, rather than me working it. Let's see how far you can get. And let me enter in the role for today. And after I do part D, we're stopping. I'll do example 2 tomorrow. I want to just break up the load because there's no way I'm doing 3/6 before the break. So the hint is there's two X-intercepts, okay, because it's already factored. It should be very easy to find those. You can also get the Y-intercept by subbing in a 0 for X. And then think about the domain. What can you not take the square root of? A negative. Can you take the square root of 0? Yes. As long as it's not in the denominator, you can take the square root of 0. Now on your Y prime, I would try to make it one fraction. When you get your first derivative, try to make it one fraction, because you should pick up a fraction, two separate things, make it one fraction. All right, so let me at least get the first three, and let's make sure we match up with you. Okay, so X-intercepts. So I'm gonna set our function equal to 0, and I can see it's already factored. So I set x to 0, and I set square root of 4 minus x to 0. Well, x to 0 is 1 X-intercept. The only way that 4 minus x can equal 0 is if x is what? 4. So there's your two X-intercepts. We got those. Now, when typing into the WebAssign, it can be picky, so make sure you put your X-intercepts as points. You should write those as points. Now you can also see your Y-intercept, because if you ever cross at the origin, you can't have another Y-intercept. That is your Y-intercept, because then it won't be a function. Okay. So your y-intercept is 0, 0, but you could have got that by plugging in a 0, and you would see 0 times that thing is 0. Now let's think about the domain. Not worried about the x out here, I can plug in whatever I want. But I can see in here that 4 is a boundary, because I get 0. Now I'm gonna think. So I know I can plug in a 4. But the question is, can I plug in numbers right to 4 or left to 4? Which one is gonna work? So what happens if I try to plug in a 5? Yeah, it goes negative. But anything left of 4, 3, 2, 1, 0, and the negatives, they're all fine. So you can see your domain is what? Negative infinity to 4. Okay. All right. And I'm just doing that through thinking. The other way you can always do it on a square root is if you take the inside of a square root and say it has to be greater than or equal to 0. And then I'll just add x. 4 is greater than or equal to x, or x is less than or equal to 4. Same answer. You can always take the inside and say, hey, it has to be greater than or equal to 0. All right, now let's find the derivative. So we're in a good shape. Now remember what we said here. It's a Nike swoosh, right? So I like to plot what I know, 0, 0, and 4, 0. There's that. Now I know it goes which way forever, left or right? From 4, it goes left. The question is, it's either doing this, right, or it's doing the other one. Can't do both, then it'd be a fish. And fish are not functions, not that kind. So it's one or the other. So this is where I'm going to need my calculus to know where my extrema is, okay, to find my max or my min. So now, what's the method you're going to use for finding the derivative there? What did you have to do? Product rule first, and then we'll do chain rule. So first it's product rule because you have a function times a function. So it's u prime v plus v prime u. So there's that. If u is equal to x, then u prime is 1. And if v is square root of 4 minus x, then v prime is. So the way, remember how we do the derivative of a square root. It's the derivative of the inside, which is what? Over 2 square root. Okay. So u prime over 2 square root of u. And then I sub everything in. So let's see. 1, v is square root of 4 minus x. Plus v prime, negative 1 over 2 square root of 4 minus x. Times u, which is x. Okay. So this was my hint to you. My hint was, don't leave it as separate fractions. 2 things you don't want to do is leave it as separate fractions or have a negative exponent. So I turned this plus or minus into a subtraction, and I can see that the common denominator has to be 2 square root of 4 minus x. And what's nice about that is now your numerator will not have a radical in it. Okay? So I'm going to go ahead and get a common denominator of 2 square root of 4 minus x. Multiply this guy by 2 square root of 4 minus x. That way, when these 2 things multiply, you just lose your radical and you get 4 minus x. So you have 2 times the quantity 4 minus x over 2 square root of 4 minus x. And let's see what we get. 8 minus 2x minus x, I get 8 minus 3x over 2 square root of 4 minus x. Okay. Now, you can set the top to 0 and the bottom to 0, but here's the thing, on the bottom, you already know 4 is an endpoint. So you're going to get 4 again when you set the bottom to 0. Well, that's good. I already know that's an endpoint. And then 8 minus 3x, set that equal to 0. So you get 8 equals to 3x, or x is 8/3. So 8/3 is your critical number. That's where your any extrema is going to be. All right, so now I'll do a little number line here to help me. Here's 8/3, somewhere right in here, right? 2 and 2/3. So now, and remember 4 is an endpoint, so actually I can stop my number line there. Okay, and now you gotta test, and here's your derivative. So my y prime is 8 minus 3x over 2 square root of 4 minus x. So I'm gonna plug into that. And really, I know the bottom is always gonna be positive because when you do square root, you get a positive answer. So I would plug in a 3, and I'd probably plug in a 0. Those would be my two test points to see what type of answer I got. Okay. All right, so let's see, if I plug in a 3, let's see what we get. So if I do y prime of 3, I get 8 minus 9 over 2 square root of 1. All I care about is the sign. What's the sign of that going to be? Negative. So it tells me that we're decreasing first here. So I am going to get the swoosh. Okay? Then I'll plug in a 0, because again, I'm just wanting slope. What's the slope going to be? So now I do y prime of 0, and I get 8 over 2 square root of 4. All I care is that it's positive. I don't know what am I doing? I'm silly. Sorry. I don't know why I was putting my stuff underneath the line. All right, there you go. So now you know it bottoms out at 8/3. It goes like that. Okay. Good or no? Question? I'm just testing points. Did I do something that doesn't make sense here? So 3, right? That makes sense. Remember a first derivative test. If it's a negative, it tells you it's decreasing. See, so.
They're not like that's backwards.
What?
It would be like negative.
Yeah, it's backwards.
Oh my gosh, yes.
I was just like looking at that.
I don't know what I'm doing. I wanted it to look like that.
Yeah.
Sorry. Yeah, you're right. It is backwards. Just we would like to delete that from the video. All right. At least we got our signs right. So look, this and this. Let's try this again. Increasing, decreasing. How about that? Is that better? So it's an upside down swoosh. There we go. I need a break, man. All right. Is that better?
Okay.
Now, what else could we find? Probably, what do we need now? Look at all that stuff. Intercepts, we got extrema. Got to plug that 8/3 in. That's a bit of a pain. That's not gonna be fun. And you plug it into. You just plug it into here though, but it's just not gonna look pretty. Like, don't plug it into here because you're gonna get 0. Plug it into your y. So we know. So we've got all this, which is good. I can see that it has a relative max at 8/3, but I'll just plug my 8/3 in and I get 8/3 square root of 4 minus 8/3. Well, that's 4/3 because your 4 turns into a 12/3. Everybody good with that? All I did is plug it into this. That's my y. So this turns into 8/3 square root of 4/3. And that's not pretty. That's that. All right. Is that, what I'm doing is I'm just doing the minimum to get the graph. I don't think for me, if I'm looking at it, it looks like it's always concave down now. It may not be, because, right, I guess, could it have like a little subtle change that we don't see? See, could it do something like that? If it does something like that, then that's concave up, right? Or do I have this wrong? Is it going like this and then like doing like that? Like, see, I'm assuming the whole thing's concave down, but I could be wrong. How's the only way we're gonna know if it's always concave down?
Second derivative.
So you'd have to find the second derivative to this. Okay, so let's stop right here. it's not good, okay? But it's not as bad as it looks. Because think, all I've gotta do, my denominator is just gonna be this thing squared, right? When you do quotient rule, I already know that the bottom is gonna be squared, so there's that, right? You're gonna square that. Well, you're still gonna get a 4, which is the endpoint. You don't care about that. We really just care about how the top works out. So let's think about this. It's gonna be u prime v. So what's the derivative of the top? -3 times the bottom, 2 square root of 4 minus x, plus v prime. Now I gotta take the derivative of the bottom, so let's see. Oh, I'm sorry, not plus v prime, don't let me make a mistake, it's minus, right? U prime v, u prime v, minus v prime u. All right, so let's see, the derivative of the bottom. 2 times, so we did square root of 4 minus x earlier, it was -1 over 2 square root of 4 minus x, times u, which is 8 minus 3x. So now, I know it looks awful, but all we gotta do is worry about is solving that equation. And I know it looks very bad, but it's not that bad. And I'll show you why in just a second. So here's what I wanna do, because it's a lot going on right there. Take a second, make sure you've got the u prime v minus v prime u. Again, I'm not worried about the denominator. So I can see this as -6 square root of 4 minus x plus, see these two 2's will cancel, minus a negative turns into a plus, 8 minus 3x over square root of 4 minus x. So, looks bad, but remember what I said, always take and make it into what? Because look, we're gonna set this equal to 0 in just a second, because that's how we get our point center inflection. So we're gonna take this and get what I always say when you have separate fractions. Common denominator, what's my common denominator? Yeah. So again, typically with square roots, when you're doing product or quotient rule, one will stay in the numerator, then it goes into the denominator when you take the derivative. So you know you're gonna end up getting the common denominator with the square root. And what happens is, all right, so let's see, we get -6 times 4 minus x plus 8 minus 3x all over square root of 4 minus x. Again, I could care less about that square root of 4 minus x because it equals 4, and I already know what 4 is. 4 is an endpoint. So now, this is just a linear equation, algebra 1. All we gotta do is solve that. Figure out what we get for x. So let's see, we get -24 plus 6x plus 8 minus 3x. Make sure I did that right. And it looks like we get -16 plus 3x is 0. And my fears have been I think we're okay. I think we're okay. Make sure I didn't make a mistake anywhere. U prime v minus v prime, the derivative of the inside over 2 square root times u, okay? There's that. 2's cancel. Minus a negative turns into a plus. Good. Common denominator. Good. -6 times 4, -24. -6 times 3x. Okay. Yeah, we're good. Why are we good?
Outside of one.
Yeah, 3x is 16. X is 16/3. What's 16/3? About, yeah, 5 point something, right? Forget about it. Hey, which I told you. So now we know on these swishes, if you ever get a swish, there is no point of inflection. So save so anytime it's like x times the square root, like x plus 3, x minus 4. On a swish, there's no inflection point. You can save yourself some time. We're stopping there today, by the way. So tomorrow, remind me I have this, can you write this down, everybody? -x plus 2 cosine x, 0 to 2 pi. We'll graph that one. And then I'm gonna do, where I give you the graph of a function, you gotta then draw the derivative, or you gotta then draw the second derivative. We'll do those, and then we'll be done for the break, okay? Okay, I'll stop that. That's enough.